Good day, everyone, and welcome to our Science 8 class. This is Teacher Donna from F. Bangoy National High School of DepEd, Davao City. Are you guys ready for another exciting science lesson? And so am I. Let's get started.
I want you to take a look and observe these pictures. What is common in these situations? What can you say about the moving vehicles, the running animals, and the people in motion? Have you ever wondered what causes these things to move, fall, and rest around us?
Do you have any idea of what our lesson is all about today? Worry no more because this is made for you. I am here to help you learn more about this lesson. For today's discussion, we will be exploring the concepts of Newton's law of motion.
Reminders to all our students that this video presentation will serve as your guide for answering your Module 2 in Science 8. I hope everyone will be able to discuss, learn, and share your thoughts about our topic. If you have any questions, please comment down and we will answer. Thank you.
Our topic is taken from the most essential learning competency of Department of Education, and that is infer that when a body exerts a force on another, an equal amount of force is exerted back on it.
These are the objectives that we need to learn. First, describe what are the laws of motion and how are they different to each other. And second, infer what are the laws of motion in connection to our everyday life application.
So today, we will explore the Newton's 3 laws of motion. Let us begin with the first one.
In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked on the ground would keep moving forever, or after some time, would it naturally stop moving? However, the ball will continue to move unless an object or force stops it. Here comes the Newton's first law of motion, which states that a body in motion remains in motion and a body at rest remains at rest unless acted upon by an external force. A common example where inertia can be observed is when you are riding on a bus. Initially, the bus is at rest. When it starts to move, your body has the tendency to move backward. On the other hand, when the bus suddenly stops, your body has the tendency to move forward. When the bus either starts to move or suddenly stops, your body has the tendency to change your state of motion. You have also experienced Newton's first law in a swing on a playground. In order to start swinging, you have to use a lot of force, but once you get going, it can be hard to stop.
And that's all about the Newton's first law of motion, law of inertia. Let's move to the next, the second law of motion.
The second law of motion, law of acceleration, states that the acceleration of an object depends on the mass of the object and the amount of force applied. In mathematical terms of Newton's second law, force is the product of mass and acceleration, and is written as force is equal to mass times acceleration. Think about it. full shopping cart versus an empty shopping cart. Which among these two carts need more force to accelerate? Correct. The one with the fully loaded cart needs more force to accelerate, because the greater the mass of an object, the more force it will take to accelerate the object. That simply means to cause an object to accelerate or speed up, a force must be applied. The more force you applied, the quicker you accelerate.
And that's all about the second law of motion, law of acceleration. And now it's time to explore the third law of motion.
What happens when two objects interact with each other? The third law of motion states that for every action, there is always an equal and opposite reaction.
These action and reaction force pairs are very evident in some of our daily life activities. Let's take a look.
What happens when you place an object on the table? The object exerts a force on the table, and the subject exerts an upward force on the object. There are two forces that result from this interaction: a force on the table and a force on the object. The magnitude of the two forces are the same, but the directions are opposite. These forces are called action and reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. Another example is when you are riding a bicycle. When you push the pedal, the parts of the tire which touches the ground push it backwards, and the ground also pushes the tires forward with the same force. So the parts of the tires and the earth form a pair of action and reaction. Also, the same principle that allows rockets to launch or jellyfish to swim. By exerting a force downward, an equal and opposite force pushes upward and the object accelerates. We can also see the third law of motion when birds fly. Their wings press down against the air. The air pushes up their wings, allowing them to move upwards. Another good example of this law is skateboarding. The skater pushes backwards against the ground with their foot. The ground pushes forward with equal force, since the wheels of the skateboard reduce the friction between the person and the ground, so they are able to move forward for some time before forces slow them down again.
Now let's sum it up. The first law of motion, law of inertia. A body in motion remains in motion, and a body at rest remains at rest unless acted upon by an external force. The second law, law of acceleration. The acceleration of an object depends on the mass of the object and the amount of force applied on it. And the third law, law of action-reaction. For every action, there is an equal or opposite reaction. So that's all about the three laws of motion. These three laws are very important for us to understand what causes things to move, fall, and rest around us. That ends our science lesson for today. See you on our next science class. Good day, everyone!